Hello everyone, welcome back to my channel. Today marks the beginning of this series and we are going to be talking about computer networks. We are going to see what is the need for learning this and why is the networking industry so important. I'm going to give you an overview, discuss about the job opportunities and go through some basics today. Hopefully this can generate some interest in this subject and help you pursue a career in this field. This entire series is going to be about interview prep, so I'm not going to dive into the basics. I'm going to give you some pointers. You can take it offline, look it up, and if you have any doubts, then reach out to me. At the end of this series, I'm hoping that we can understand how the internet works, how two computers are able to communicate with each other while being in two completely different geographical locations. We are also going to learn about the hardware and the software aspect of the networking devices. We'll be learning about the different virtualization techniques and how they are being deployed on the cloud now. And what is the future of this industry? So let's talk about some of the job opportunities that opens up to us once we have the basic knowledge of computer networks and we understand the fundamentals. We could get into the internet industry, which is basically the internet service providers like AT&T, Verizon, Airtel, Jio, or the companies which produce the networking software and the hardware like Cisco, Juniper, Broadcom, etc. We can also get into the cloud industry like AWS, GCP, Azure. All of this will provide services like firewalls or the companies which produce the networking software and the hardware like Cisco, Juniper, Broadcom, etc. We can also get into the cloud industry like AWS, GCP, Azure. All of this will provide services like firewalls, DNS as a service. Uh, all of this require you an understanding of networking, how routing works, how firewalls work, how to block certain IPs, all of that. So it's very important to have this knowledge. Now, a lot of new companies are coming up which are using artificial intelligence and machine learning to do some kind of analytics to determine or predict which area, in which area, at what times of the day, certain links will be more congested where there is more internet traffic and suggest to use different links via different paths so the traffic can be routed efficiently with low latency and high throughput. So a lot of new companies are coming up with this. Now we also have virtual reality where Meta and Apple have their own virtual reality headsets. The vision of this product is basically in the coming few years you are able to have a meeting virtually in a common space where I am sitting at my home and you are sitting at your home, but we both are able to meet at a certain specified location and interact with each other in real time. For this to happen seamlessly, there has to be a really high throughput bandwidth, low tolerance, very low tolerance. And for all of this to happen in real time seamlessly, a lot of new technology, a lot of new protocols need to be developed. So the networking industry has a future in this particular field as well. The other type of jobs which we can focus on is the network architects, network designing, network engineers who configure the devices, maintain it, and help the company keep running their network. So every big company who has a lot of branches which are located in. So what is a computer network? A computer network is a connection between two or more networking devices. These devices could be computers, routers, switches, mobile phones, laptops. Anything that is able to connect to the internet has some kind of networking software in it. And these devices are referred to as networking devices. When two networking devices are communicating with each other, they are part of a network. Now let's see what are the different kinds of networks. So the first one is personal area network. In this network, we have, let's say for example, a PC which is connected to keyboard, mouse and a printer. It could be either connected in a wired fashion or wirelessly via Bluetooth, and there's always a one-way communication where we have a PC which acts as a master and the rest of the devices act as slave. Another example would be a phone connected to a headphone, right? So that's like the smallest type of a network, which is personal area network, where there's just one-way communication. So the next type of network we're going to talk about is the local area network, which is also called as LAN. The LAN is designed to connect multiple networking devices within a limited geographical distance. So let's say a small office, or let's consider my home. So I have multiple devices connected to my Wi-Fi router, and my Wi-Fi router, once I form a connection with it, it provides me with an IP address which is 192.168.1.2 or 1.3 from a private pool of IPs. Why is it private? Because I'm in my local area network, so I don't need a public IP, right? So let's say I have 10 devices like that. There's so many households in the entire world. Now if all of them start getting a public IP, then we will exhaust the IP, which is like a 32-bit value, which we already have, and now we have IPv6 to accommodate more devices, right? So we came up with this concept where we have a pool of IP addresses which are private and a pool of IP addresses which are public. Whenever I'm part of a local area network, I will use a private network address, right? So I can have a same IP address as in my home, and you can also have the same IP address at your home. But since we are part of the local area network, and once we want to communicate with each other, what happens is we use a public IP that time once we have to send the packet out in the internet, right? So I'll just give you an example. Let's say I'm trying to communicate with you, right? We both are in different locations. I'm connected to my Wi-Fi router and you are connected to your Wi-Fi router, and we have got a certain, let's say we have got 192.168.2, right? Let me just show it to you. Let's say I have a laptop which is connected to my ISP's router, right, which is provided by AT&T. Okay, so I'm connected to this router and my IP is 192.168.1.2. I also have a mobile phone, 192.168.1.3, right? And let's say this is another LAN over here, LAN network, where you have your laptop which is connected to 192.168.1.2, right? So this is your LAN, right? And this is my LAN. Now this is your ISP's router, which is provided by, let's say, maybe Verizon. Okay, and what happens is this is the internet. Okay, and I have more routers over here. Now this IP address which has to send the packets out into the internet, we'll be using a public IP over here, public IP, right? So let's say we have something as 30.1.1.1. Okay, this is the IP address that is used to send the packet out, and this is the two links over here, right? We can see the two links. This is 40.1.1.1 and I have two addresses again over here, two interfaces over here on this router, which is my ISP, another ISP, right? So I'll have a public IP of, let's say, 20.1.1.1. Now what happens is, this is a message which I need to send, right? 192.168.1.2. It's a private IP. You also have the same IP. So what I'm going to do is, when I send the packet out into the internet, I have a protocol running on this device called as NAT, which will translate the private IP to the public IP. Okay, and this device will see that this packet has to go to you, and for this device it will show that the destination IP is 3111 or 4111. Based on certain routing protocols, it will choose whichever path is the best. It will take that particular path, and once it reaches you, right, once it has reached you, we can see that the destination IP, say it was 3111, so this was the best path, so it chose this path. Now this device has received it. Now this will basically look into its own table, own forwarding table or routing table, and make the decision that this particular packet has to go to you based on the IP address and the port number. Okay, so the IP address, MAC address, port number, all of this I'll teach you in detail in the coming slides. This is just a basic overview of how the packet is routed, right, from one part of the city to another part of the city, you can say. So this is what happens, and now, so this is one LAN 1, and this is another LAN 2. And this is the internet. Now this LANs, including the internet, is called as a metropolitan area network, MAN. Now let's say I have more LANs over here, right? LAN 3, LAN 4, right? And this is one MAN, right? And multiple such MANs will constitute a WAN, which is nothing but wide area network, right? So these are the different types of networks we have over here. Now, one thing what I wanted to achieve with this is, so don't worry about the NAT, what protocol is that, how the packet is getting routed, how did it choose this particular path as the best path and all. Don't worry about the source IP, destination IP, and how this is transmitted back to this particular device. All of this we will learn in the coming streams. I'll teach you in detail about layer 3, layer 2 addresses, how that decision is made, and all of that. For now, I just wanted to make you understand that, this is how the communication happens. These are the different types of networks. But what I want you guys to know is about the private IPs, the public IPs, how the subnetting works. Like this is part of /24 subnet, right? Like that we can have /16 subnet, /8 subnet. So it's important that you guys learn these basics, right? Now, since let's say these two devices are part of the same network, okay, Why? Because this is part of which network? That could be a question. So this would be part of 20.1.1.0/24 network, meaning if this is 21.1.1, then this has to be 21.1.0 to 255. It has to be one of these numbers. It has to be one of these IPs because they are both part of this network. So I'll just mention a link below on how to determine the subnet and the mask part of it, right? So this can never be, say, 20.1.2.1 when the network is this. You cannot configure that. If you try configuring that IP address on this particular interface, then it will throw an error. So all of this is a job of a network engineer to configure the routers with the appropriate IP addresses, right? So let's see another aspect over here. What else can I teach you over here? That IP addresses, public, private, subnetting, and yeah. So now let's talk about the different devices, the networking hardware, right? So we have, this is called as a router, right? Now the router is performing many kind of activities, right? So it needs to be very smart. It needs to make that decision quickly. So the router basically consists of a CPU. It consists of RAM. It uses RAM to look up, to quickly look up the routing table, to know which IP it has to go to, and then appropriately forward it onto that interface so it can go out of that interface. Then it has an operating system that processes the packets that are received. It also has the network interface cards, right, NICs. And then over here I could also have a layer 2 device, right? I could have a layer 2 device that connects multiple devices, right, like switches, bridges, hubs. So these are the hardware device. These are the components of a device. Okay. Now let's talk about the software part of this router, right? So the router's software stack basically has 7 layers. The application layer is the topmost layer, then presentation, session, transport, network, data link, and physical. So the physical layer is basically the medium in which the packet is being sent out. It could be the coaxial cables, the fibers, optical fibers, etc. The data link layer is basically used for error detection and correction. It's used to encrypt the data frames whenever necessary. It basically has a MAC address which makes sure which particular device it has to go to. And then the third layer is a network layer, which is basically the internet protocol layer or the IP layer. And this is where you have the source IP and destination IP addresses, which is to be populated. Then there is a transport layer which provides reliable communication between two systems, and it ensures that the data is transferred accurately without issues. Then we have the session and the presentation, which was there in the earlier models, but after a while, which is a more widely known reference model, which is the TCP/IP model, does not use these two layers, the session and the presentation layer. So this is basically to form a connection, a reliable connection, and this is not used anymore. And the application layer is where you run your application, like file transfer, email, HTTP. So it's basically anything that provides any service. And the underlying protocols that are used for the communication. Now, for example, right, when you open a web page, so what happens is I'm sending information from my computer to that particular web page server, trying to reach that server, right? So host A is nothing but me. Okay, I am the source, and the destination is the address which I'm trying to reach. And so how it goes is, at the sender side it is top down approach, and at the receiver side it is bottom up approach. So the application layer is the HTTP, right? So uh, is it's the application layer protocol, like HTTP, is used to retrieve the data from the server. The transport layer then packages the data into a TCP segment and sends it to your device through the network and the data link layers. This process ensures that the data is quickly and reliably sent, allowing you to browse that particular web page. So this is the software stack. So whenever we form a packet, right? So packet is where you're sending the data. Now the first packet, if it's part of HTTP, it would be a HTTP request, HTTP response. These are packets which are sent out from the device, right? Now these packets are encapsulated with the source IP, the destination IP, the source MAC address, the destination MAC address, whether it's TCP or UDP based, it has its protocol number. All of that information is there in this packet, right? And this is encapsulated from top to bottom. So layer 2, so what will happen is layer 5 will send the information to layer 4. Layer 4 will put its header and send it to layer 3. Layer 3 will put its header onto layer 2, and again it will send to layer 1. Like that, packets are sent out from onto the median, and it's again received by the host B. So host B will, layer 1 will receive, it will decode the packet, it will remove the encapsulation and send it to layer 2. Layer 2 will decode the packet, remove its header and send it to layer 3. Layer 3 will take whatever it needs from it, remove it and send it to layer 4. It's like that. That's how it works. Right? So this is the software stack of a device, of any device. Guys, so these are the concepts which I want to go through. These are the basic concepts. It's important that you have in knowledge about this. So I just wanted to make sure that you guys know what's important and what's not. So do understand how the subnetting part works, how to derive an IP from a given subnet, and the OSI layer model as well. I'm gonna paste a link below in the description, just go through it. We are going to discuss each layer in detail when we talk about that particular layer in the coming lectures, so don't worry about it if you didn't understand. I'm going to show you how the encapsulation is done, what are the fields which get encapsulated, and how the packet is sent out, right? So but still, I just want you guys to have an idea. So this was just the first video of the series. It was just an overview, the kind of jobs you can get, and some basics on IP addresses and the software stack. Hopefully you liked the video, and we will start going in detail of what we discussed today, one video at a time. Thank you.